All right, so our topic for this video will be going to deal with the straight line forecasting model. So this is the first type of time series model forecasting actually. And here for the straight line forecasting, it is one of the most straightforward time series, as what I mentioned to you before, forecasting technique that is often used when the data shows a linear trend over time. So this method assumes that the future values of a variable will follow the same linear trend as the past values. So it will usually you deal with linear as always. So if your x and y intercept, if you're having like this, then they are something like that. So if your historical data, or I mean, this is your historical data, so your future data, something it will also something related to this historical data. So it will become still linear as well. So equation we're giving right now the y of time, which is equals to the intercept A and plus the slope times the time. So let's actually deal with that one by one. So this is the forecasted value at time t, and that in this is the intercept A, the starting value or the value of y when t is equal to 0. This is the value of this is the slope, the rate of change per unit of time, showing how much the value increases or decreases. And this t is the time period like day, month, or year that we're trying to achieve or trying to forecast them. So let's actually there will be steps in the straight line method as well. You have to plot the data, you have to calculate the slope, you have to calculate the intercept A, you have to make forecast, you have to plot the straight line. Now, identifying the plotting the data, plot physical data on a graph with time, like years and month, and the x-axis and the variables. So you are forecasting like sales and production in the y-axis as well. So remember, your imo x-axis will be the months or years, and here then will be the sales. So that is everything, the results. Now, calculating the slope, where the slope is calculating by finding the average rate or of change over the period, where you are using this here. So n summation of t times yt, then summation of t times summation of yt, then n times summation of t squared, and minus to this summation of t wherein that is squared. So formula here where your n is equal to the total number of data points, and your t is the time periods, and yt is the observed values, and the summation represent the sum of all over all the data points. Now we'll begin to deal with that one by one later on in our example. You have to calculate the intercept A as well. So intercept A, you're using this formula. You cannot get the intercept A if you were not able to get the slope first, because you do have slope here. So that is the summation of yt and minus the b or the slope, then times the summation of t and over to n. Then you have to make the forecast where you are using the yt as equal to a plus b times c to forecast the future values, and plug in the periods you want to forecast to obtain the values of yt. That is easy. Now, plot the straight. Once you have the values of a and b, plot the straight line on the graph. This line represents the best alternatives of the trend in your historical data. Since you're having historical data already, you can just plot the future trend, something like that. So now we do have example one here right now. So suppose we have the data for sales y over 5 periods time, wherein your period is 1, 2, 3, 4, 5, and your sales is 20, 25, 30, 55, 40. As a business owner, you want to forecast future outcomes using the straight line model. So you have to identify the n, you have to identify the p, you have to identify this and everything. So slope, intercept A, and y6 to y10. Now, identifying them, that is n is equal to 5, because, you know, that is 1, 2, 3, 4, and 5. So they are 5, which is the total number of periods. So um, that is their total period is giving 5. Now, what about the summation of p? When we say summation of p, 1 plus 2 plus 3 plus 4 plus 5. So that is 15, which is the sum of the period. So summation of y. Why is it summation of yt? Because here then, so summation of yt, this is signifying day 1. So 20 is signifies the address T1. 25 address T2. T3, 30. That's why it's somewhat YT. So 20 plus 25 plus 30 plus 34 plus 40, that is your summation of YP, that equates to 150, which is the sum of the sales values. Afterwards, you have to identify the summation of T squared. So your T squared right now, 1, 2, 3, 4, 5, you will square itself and sum everything. So that will equates to 1 squared, 2 squared, 3 squared, 4 squared. So 1, 4, 9, 16, 25, you will add them all. It will become 55, which is the sum of square of the period. Now, times, you will multiply the T times to the YT. So 1 with a specific Y. So it will be something like that. So suppose that it will become here's 1 times 20 times plus 2 times 25 plus 30, 3 times 30 plus 4 times 35 plus 5 times 40. That's how you will build that one. Then 20 plus 50 plus 90 plus 140 plus 200, it will equates to 500, which is the sum of the products of period and sale. Now, we were able to identify that all. What we'll need to do right now, we'll be going to find the slope already. For the slope, we'll be going to deal with the first step. So the first step, you have to plot the data, which your historical data. The x-axis is the time. So there will be the x-axis, will be the time, 1, 2, 3, 4, 5. And your y-axis will be the sales. This will be the result here. So your x and the previous will be your 1 is 20, then your 2 is 25, your 3 is 30, and your 4 is 35, and your 5 is 3. So you can somewhat determine right there that there is a linear relationship for the historical data first. Now, after that one, you have to calculate the slope, wherein your n is equal to 5 times the summation of t and yt, that is 500. So 5 times 700, that equates to 2,500. Now, summation of t is 15 times summation of yt is 150. So 15 times 150, that equates to 2,250. So you will deduct them. It will become 250. Now, your n is 5. Your summation of t squared is earlier, that is 55. Now, your t, then square that one. Your summation of t is 15, then you will square that. And that is 5 times 55 is 275. Then 15 squared is 225. You will deduct that. It will become 50. So 250 divided by 50, it will become 5. So your slope right now is 5. So there you have it. You can calculate the intercept right now where your summation of yt that equates to 150 earlier, then minus your slope, which is 5, then times to the summation of time, which is 15. So over the n, which is 5. So you will certainly check here, you will deal with 5 times 15, that is 75. So 150 minus 75 is 75 over 5. So 75 over 5, it will become 15. So your A is 15. So since we do have already A and your slope, we can calculate already the forecast data. So for make forecast y6 to y10, so your y6 right now, since yt is equal to a plus b times c, so it will become 15 plus 5 times 6. Since 6 is the year that here then y6, so that you can put right there 6. 15 plus 5 times 6 is equal to 15 plus 30 that equals 45, something like that. Here then, for y7, you'll come 15 plus 5 times 7, you'll come 15 plus 35, and it will become 50. Now, for y8 equals 15 plus 5 times 8, it will become 15 plus 40, equals to 55. For y9, it will become 15 plus 5 times 9, it will become 15 plus 45 is equals to 16. And for y10, it will become 15 plus 5 times 10, and 15 plus 50 equals to 65. So that will be the forecasted data. So afterwards, the last step, you have to draw everything. So that's the case that you will be going to deal with. The last one, you have to draw everything since the result is in your forecasted data. This will be the your 6 is 45, your 7 is 50, then your 8 is 55, then your 9 is 60, so your 10 is 65. So that's somewhat the example for your historical data. So that shows a linear increase in sales over time. So you can definitely explain that there as well, that there is a linear relationship in the result. So that's how you will deal with the straight line forecasting model actually. So thank you so much. Hope you understand that. I'll be going to give another example in the another video as well. Thank you and have a great day.